If your Excel model freezes every time you hit calculate and the status bar mentions calculating 1% forever, external links are a prime suspect. Linked workbooks can turn a clean model into a slow, fragile chain reaction. The tricky part is that the file can look simple, yet still recalc like it's doing heavy math. That's because Excel is not only calculating formulas, it's also resolving where linked values live, whether sources are available, and what changed upstream. And if one link is unstable, everything downstream waits. The goal is not to delete links blindly. The goal is to make links predictable, minimal, and easy for Excel to update. In the next few minutes, you'll learn a practical workflow to diagnose what's slow, reduce unnecessary link calculations, and redesign the model so it recalculates fast, even when sources are large. You'll keep the flexibility of external data without the lag. Next step. First, let's align on what external link recalculation really means. When a formula points to another workbook, Excel has to decide if it can trust the last stored value or if it must refresh it. If the source workbook is open, Excel can pull live values, but it may also recalc the source first. If the source is closed, Excel can sometimes use cached values, but it still has to validate links and dependencies. Network paths add another layer, because Excel may pause while checking availability or permissions. And if your model uses volatile functions, like indirect or offset, Excel often recalculates more than you expect. Another hidden cost is link traversal. Excel walks through the dependency tree to figure out what depends on what, and external links make that tree bigger and harder to optimize. Understanding these mechanics helps you choose the right fix, instead of guessing. Next step. Before changing anything, confirm that links are the bottleneck. A simple test is to switch calculation to manual, then trigger a full calculation and time it. If the delay happens even when you change a single local input, that suggests a wide dependency chain. Next, temporarily break the chain in a safe way. Save a copy of the file, then replace external link ranges with their current values. If recalculation becomes instant, you've proven the cause. Another clue is when the workbook recalculates on open, even if you change nothing. That often indicates Excel is trying to refresh links or resolve missing sources. Also watch for updating links prompts because they can hide repeated checks. The point of this step is to avoid deep redesign when the real issue is something else, like heavy conditional formatting or large pivot caches. Next step. Now inventory your links. Most slow models have more links than the author realizes. You might have formulas, named ranges, charts, data validation lists, or conditional formatting rules pointing outside. Start by listing all linked workbooks. Then identify which ones are critical and which ones are legacy. A common pattern is a link explosion, where one imported sheet is referenced by hundreds of formulas across many tabs. That multiplies the work Excel must do when anything changes. Another pattern is duplicate links to the same source, but through different paths, like a mapped drive in one place and a UNC path in another. Excel treats those as different, which can cause repeated checks and inconsistent updates. The outcome you want is a clean map: which sources, which sheets, which ranges, and why they exist. Next step. One of the biggest speed wins is reducing how many external references exist without losing information. The best practice is to pull external data into one dedicated staging area, then have the rest of the model reference only that local staging sheet. This turns thousands of external formulas into a small number of controlled imports. It also makes dependencies easier for Excel to manage, because most formulas become internal. If you need multiple tables from the same source, import them once, then create local structured references. And if you only need a snapshot, store values, not links. This approach also improves auditability, because you can quickly see what came from outside and when it was last refreshed. You're not removing external data, you're containing it, so recalculation doesn't constantly chase links. Next step. Next, tackle volatile and hard to optimize formulas that make external links worse. Indirect is the classic culprit, because it hides references from Excel's dependency engine. That forces broader recalculation, especially with external paths. Offset can do the same. Even cell, now, and rand can trigger recalculation more often than you intend. If you're using indirect to build a dynamic file name, consider a different design. Keep the external import fixed and choose scenarios locally with lookup tables. If you're using offset for dynamic ranges, consider structured tables or index-based ranges, which are usually more calculation-friendly. The rule is simple. When external links exist, you want Excel to clearly see dependencies. Hidden dependencies make Excel recalc defensively, and defensive recalculation is slow. Next step. Let's talk about the source workbooks, because your model can be fast, yet still wait on a slow source. If the source file is huge, has many volatile formulas, or recalculates slowly itself, your linked model inherits that delay. One strategy is to convert the source into a data provider file. That means minimizing formulas, keeping clean tables, and storing final values where possible. Another strategy is to export the needed ranges into a separate lightweight extract workbook and link to that instead of the full operational file. Also consider whether the source must be open. Sometimes keeping the source closed and using stored values is faster and more stable, especially on networks. The key is to treat the source like an upstream dependency. If upstream is unstable, downstream will always feel slow. Next step. File paths sound boring, but they're a real performance factor. When links point to network shares, Excel may pause to confirm the path exists, check credentials, and handle latency. If the network is inconsistent, recalculation can feel random. Standardize paths across the model, so the same source is referenced the same way everywhere. Avoid mixing mapped drives and UNC paths for the same file. Also avoid long, deeply nested folders when possible, because path resolution can be slower and more error-prone. If you work in an environment with offline sync tools, be careful with cloud placeholder files that aren't fully available locally. Excel can stall while the file downloads. A practical approach is to keep linked sources in a stable, always available location, and keep file names fixed. Stability reduces both delays and link breakage. Next step. Another common slowdown is calculation scope. Many models recalc far more than they need to because everything is connected to everything. The fix is modular design. Separate inputs, staging imports, calculation logic, and outputs. Then minimize cross-sheet dependencies, especially from outputs back into calculations. If you can, compute intermediate results in one place and reuse them, instead of repeating the same linked lookups across many tabs. Also consider replacing repeated VLOOKUP style patterns with a single local key table and a few centralized lookups. Even better, pull external data into a local table and use one set of lookups against it. Excel performs better when the calculation graph is shallow and predictable. You're aiming for a model where a small input change triggers a small recalculation, not a workbook-wide storm. Next step. Now let's address a subtle issue: external links inside named ranges, tables, and formatting rules. You can have a workbook with no obvious external formulas, yet it still recalculates slowly because a name refers to an external workbook. The same can happen with conditional formatting formulas that reference linked ranges, or with data validation lists pulling from another file. These features can trigger recalculation and link checks more often than you expect, because Excel evaluates them during editing and navigation. A strong practice is to keep all names local unless there's a clear reason. Keep validation lists in a local helper table, and for conditional formatting, reference local staging data, not external sources directly. This is one of those fixes that feels small, but it often removes the last mystery lag when everything else looks correct. Next step. Sometimes you actually want fewer recalculations, not faster ones. In that case, manage when links update. If your workflow doesn't require live updates every time you edit a cell, keep calculation manual and refresh on demand. You can also set link updates to prompt, so Excel doesn't try to refresh it open unexpectedly. For models used by others, add a clear refresh data step, so people know when numbers are current. The trade-off is freshness versus responsiveness. Manual control gives you speed while building and editing, but it requires discipline to refresh before publishing results. A good compromise is to refresh links at specific checkpoints, like after input entry and before exporting outputs. The main idea is to stop Excel from constantly checking external dependencies when you don't need it. Next step. If you're inheriting a messy model, you need a safe cleanup approach. Step 1 is to make a backup and document the current link list. Step 2 is to consolidate links into staging, one source at a time, and confirm outputs match after each change. Step 3 is to replace dynamic external references with stable imports. Step 4 is to remove dead links, including old file names that no longer exist. And step 5 is to standardize paths and naming conventions, so the model stays clean. This incremental method matters because external link models often have hidden dependencies. If you change everything at once, it's hard to know what broke. If you change one source at a time, you can validate quickly and keep trust in the numbers. Speed improvements are great, but correctness comes first. Next step. Let's finish with a practical target architecture you can aim for. External workbooks feed a small number of imported tables. Those tables live in a staging area and are the only place external references exist. All calculations reference the staging tables locally, ideally using structured references and a few centralized lookup steps. Outputs pull from the calculation area, not directly from sources. If you need history, store periodic snapshots as values, not as links. And if multiple people use the model, keep the source location stable and avoid personal file paths. This design is not just faster, it's easier to audit, easier to hand off, and less likely to break when a file moves. If you want one rule to remember, it's this: link less, import once, calculate locally. Next step. To wrap up, external links don't have to be slow. They get slow when they're scattered, duplicated, volatile, or dependent on unstable sources and paths. If you map your links, contain them in staging, remove volatile drivers, and control refresh timing, recalculation becomes predictable again. And once the model is modular, you'll notice something else. Debugging becomes easier too, because dependencies are visible. If you found this workflow useful, subscribe for more practical Excel modeling patterns that keep files fast and reliable. And I'm curious, do you prefer external links that update automatically, or do you prefer manual refresh control? Comment with A for automatic or B for manual. I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.